Let's now take a look at the dot product and have a look at what differences there are for that in 3 dimensions. Now, the nice thing about it is, as a vector is a line segment in both 2 dimensions and 3 dimensions, the rules and the properties will remain the same in both situations. If we have 2 vectors and neither of them are the 0 vector, then the dot product will be the magnitude of each vector multiplied together times the cosine of the angle in between those 2 vectors. Now, when you talk about 3 dimensions, the angle between the 2 vectors would be in the plane that those 2 vectors are in. And remember, theta is acute or obtuse. Now, if it does turn out that one of those is the 0 vectors, so either u or v is the 0 vector, then the dot product is simply 0. So we have 2 vectors, u and v, and our dot product, we remember in 2 dimensions it was just x1 times x2 plus y1 times y2. We now extend that through to the 3rd dimension and get z1 times z2. So some product properties. So the dot product will always be in between plus or minus the magnitude of the 2 vectors multiplied together. And that's because the cosine goes between -1 and 1. It does not matter which vector comes first, so u dot v will be the same as v dot u. U dot u is the magnitude squared. We can expand out parentheses if you like, but remember, dot is not actually multiplication. It looks like we've multiplied. So a dot u plus v would be a dot u plus a dot v. And similar thing here with number 5. It looks like the difference of 2 squares, but remember, we're not actually multiplying, it's the dot product. So we get u dot u, which we know is the magnitude of u squared, minus v dot v, magnitude of v squared. And we can multiply by some scalar. Now, if u dot v does turn out to be 0, then we know that means the 2 vectors are perpendicular. And if it's out at the other extremity, so u dot v does indeed equal plus or minus the 2 magnitudes multiplied together, that would indicate that the 2 vectors are parallel. You should find that the dot product will be greater than 0 if the vectors are going in the same direction, whereas if they're going in opposite directions, then it would be less than 0. Let's do this example. We've got 3 three-dimensional vectors. We could actually prove that, what looked like expanding out the parentheses. So a dot b plus a dot c. So we'll start with a dot b plus c, but let's write them in component form. So a would be a1 in the I direction plus a2 in the j direction, a3 in the k direction. Our second vector will be b1 plus c1 in the I direction, b2 plus c2 in the j direction, b3 plus c3 in the k direction. So we'll end up with a1 times b1 plus c1, a2 times b2 plus c2, a3 times b3 plus c3. We expand all that out, and now I group them together in a particular way. So I group a1 b1 with a2 b2 and a3 b3, and then in the other parentheses I've grouped a1 c1 with a2 c2 and a3 c3, because that is, the first one is a dot b and the second one is a dot c, and we have our proof. This time let's prove these 2 vectors are perpendicular. And remember, that's when the dot product will equal 0. So we get 3 times -4 and -2 times -8 and 4 times -1, and sure enough they all add to give 0. So yes, those 2 vectors are perpendicular. Here's an interesting one. So the point A is out in space somewhere. It's got its position vector of OA, so ABC. It makes an angle with each of the axes, alpha with the x-axis, beta with the y-axis, gamma with the z-axis. Now, I've asked us to, by taking the dot product with those 3 unit vectors, prove this relationship, cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1. So I'm going to let our vector be A in the I direction, B in the J direction, C in the K direction. So I'm writing it in component form. So U dot I, so that's the dot product with I, will simply be A. Remember, I is the unit vector 1, 0, 0. But also, it'll be the magnitude of U times the magnitude of I times the cosine of the angle between. And we've defined that to be alpha. So the magnitude multiplied together, well, the magnitude of I is just 1. So the magnitude of U will be the square root of A squared plus B squared plus C squared. So therefore, I can rearrange all that and I get cos squared alpha is A squared on A squared plus B squared plus C squared. Similarly, cos squared beta would end up being B squared on A squared plus B squared plus C squared. And cos squared gamma would be C squared on A squared plus B squared plus C squared. Well, if I add the three together, we end up with A squared plus B squared plus C squared on A squared plus B squared plus C squared, which is 1. Okay, let's have a look at 5C, so playing with the dot product.